So we wanted to see how fast trash floats along the ocean. We're picking up trash along the shore for about 1 kilometer and wanted to see how far out, the trash would travel in 1 month, how far away it would come to the shore in 1 month. So we took a water bottle and tied it to a drone and sent the drone out a certain distance and dropped the bottle in the water, and then timed how long it took it to come back. And so we had a windsock to point which direction the wind was coming from, and we went straight upwind, and we actually measured the point here where the waves are breaking, and then went out further another 100 meters beyond that and dropped. I now see some waves breaking out there too, but we didn't see them breaking much where we were. I don't think they broke where we were. It's weird. So yeah, it turned out that it went about 30 meters in 10 minutes. And then as it got closer to the shore, it kind of got into this area on the side of this particular beach where the water seems to be going out. There's like a riptide, and the bottle stopped coming in. So we didn't make it all the way back to these waves. But I think we have an interesting, a realistic number anyway. So we're just flying out. Gonna drop the bottle in the water. You'll see at one point, so there's the bottle. And we're slowing down so you can see it. When we're moving, I think it's hanging off to the side too much. You'll see one point where there's a plastic bag down in the water, and the bottle only has about 10% of its volume with water. It's mostly air, and so it's sticking out of the water and it's being pushed by the wind reasonably well. And there's a trash bag, which is of course all the way down in the water, and this sort of zooms on past it. We have a website, kate.ai/sand, where we're keeping information about how much trash we're collecting every month, and also measuring how far the beach sand goes out, where the water is from some certain markers. People stole sand from, there's the drop. Yeah, so that's dropping the bottle into the water. And then the drone just kind of can follow along. You can see some seaweed, and it floats along the surface too, but it's more down in the water than the bottle is, so I think the bottle is going to usually go faster. So years ago, people stole sand from this beach. Well, not that many years ago. And so we're sort of watching the sand, if it's coming back. And it came back once, and they stole that sand. And then it's sort of come back again, but not nearly like it was before. And I'm afraid if it gets stolen again, there's just not enough under the ocean to come back a third time. Sand is produced very slowly by these fish that eat the coral, and they could get a cubic yard of sand per year per acre of coral. But here there might only be an acre, so the cubic yard per year is just not being produced in any significant way. The sand that was here before, it was tens of thousands of years at least worth of sand, and now it's gone. It used to be like 15-foot high dune, 1,000 feet wide. It was really something. But now a lot of the land that used to be there is now underwater because the sand took away so much. Anyways, there's the bottle floating along, just seeing how fast it moves. And again, we're collecting like 1 or 2 bags of trash, and we're weighing them and stuff every month. And so if you look at how far out this goes, during that, how far away the trash would come from during 1 month. You can sort of get an idea of how much per cubic mile, per square mile, how many pounds per square mile or kilograms per square kilometer or whatever you want to do. And it's not very much. So that's kind of interesting, because there's a lot of people that are all panicked about how much trash there is on the ocean. And so this is kind of an experiment to see how much trash there is on the ocean. And it's really not that much. Yep. So that's what... you could have different speeds for different size pieces of trash, and depending on how much of the trash was underwater. So there's a lot of plastic things which are floating because they're plastic. And then there's some that are floating because they're a container and they have air inside them. And then there's some that are, a little bit of water, but mostly air. And so these things are going to float at different speeds. But a very common one is a water bottle that has like 10% of water. And I think what happens is that people on the boats are setting down this bottle, and while it's full, the bottle stays there. But when the bottle gets down to like 10%, the wind can knock it over and off into the ocean. So this is very common to see a water bottle that's 10% full of water. So that was the first one, but we may try some of these other things, but clearly some things that are down deep in the water, they're going to move much, much slower. And something that's, like an empty milk jug that has no water, no liquid inside it at all, will move faster. So, anyway, just looking into that.